Welcome to the course Structure Analysis. Myself, Dr.S.Pachaiappan, Assistant Professor, Department of Civil Engineering, Aditya University. So today is a 10th lecture. We are discussing about the slope deflection method. So here we are going to see a problem of continuous beam, how to calculate the end moments, and also the we are going to draw the shear force and bending moment diagrams. So at the end of the lecture, students can able to calculate the reaction forces of a continuous beam and then draw the shear force and then bending moment diagrams. Quickly take the another example problem. So last lecture we are discussed two span continuous beams. Okay. So here also it is a two span continuous beams only. But in last example, there is only one unknown because support A is fixed, support C is also fixed. So in that case, we had only one unknown. But today I have taken two unknowns, which is theta B and theta C. Okay. So let's draw the beam. So this is our beam. Support A. Support B is a roller support. Support C also the another roller. So this is C and then D. So we are having a 45 kilonewton here in span AB. This is 2 meters and this is 4 meters. Overall span is AB is 6 meters. And the EI value is 1.5 times of I. For span CD, we are having 2 times of I. And span CD, we have the UDL whose intensity is 15 kilonewton per meter. And span CD is 4 meter long. Span CD is 4 meters long. Now what are the unknowns? At support A, the fixed end moments, it's a fixed support, so the rotation is 0. At support C is a simply supported but intermediate support. Moments will be there as well as the rotation also will be there. At support D, we are going to have the theta D. So this is support B and this is support C. So this B and then C. Then what are the unknowns now? The unknowns are theta B and then theta C. So if you calculate the theta B and theta C value, now we can able to calculate the end moments. Okay. Step 1. We'll go step by step. We are going to calculate the fixed end moments. We are going to calculate the fixed end moment. Let's consider the span AB. I am considering the span AB. So whatever may be the support condition, I am going to consider it as a fixed because I am calculating the fixed end moments. So one eccentric load is given, that is 45 kilonewton, 2 meters from the support A and 4 meters from the support B, totally 6 meters. So I am going to calculate the value of two values. One is MFAB equal to minus, the reason is you see anti-clockwise couple and this is a clockwise couple. So minus of MFAB minus of WA B square by L square, formula for the fixed end moment. So W is 45 kilonewton, this is A and this is B. Okay, 2 meters is A and this is B. So 2 meters multiplied by 4 meters divided by 6 square, I will be getting minus 40 kilonewton meter. Similar way, let's calculate MFBA. So it's a clockwise couple, so positive, and the load is uniformly distributed load. So that is formula is WL square divided by, no, we need to apply the same formula only, but slightly we need to modify it. Okay. So this is plus W A square B by L square. So here the square term will come for a B and here the square term will come for A. So that is the difference. So W is same which is 45 and A is 2, B is 4 meters and A is going to have the square term divided by 6 square. So I will be getting 20 kilonewton meter. So in the similar way we are going to calculate the fixed end moment for the span BC. So quickly we take the span BC. We are considering it as fixed and then we are marking the moment direction, and the span BC is having UDL entire span. The intensity of the UDL is 15 kilonewton per meter and the span is 4 meters. So what I am going to calculate? I am going to calculate MFBC minus of WL square by 12. Okay, let's substitute the values. Minus of 15, span is 4 meters square divided by 12. So I will be getting minus 20 kilonewton meter. Minus 20 kilonewton meter. So similar way MFCB minus, so this is minus, this is positive, WL square by 12. So same value only I am going to get plus 20 kilonewton meter. Okay. So minus 20 kilonewton meter and then plus 20 kilonewton meter. So far we have calculated the fixed end moments. Now we are going to write the equation. So for writing the equation, before that, once again we have to take the beam. So our beam is fixed at A and simply supported at B and C. Okay. So mark this is support A, B and C. We need a span also here. This is 6 meters and this is 4 meters and then span A is 1.5 times of moment of inertia I and span BC is 2 times of I. Okay. So now let's frame the equation. I am going to write the equation for MAB. MAB equal to MFAB fixed end moments plus 2EI by L into 2 times of theta A. So the first term going to get 2 times of theta and second term is going to get simply a theta. So 2 times of theta A plus theta B minus 3 del by L. I am not writing because in this problem the support settlement is not given. Okay. So simplifying this upon, we will be getting MFAB already we are calculated, which is minus 40 and then plus we have here 2 multiplied by, and I forgot to substitute the value of span. Let it substitute it here. So 2 times of E, the span AB I value is 1.5 times of I divided by the span 6 meters. Okay. So 2 times of theta A plus theta B. I am going to make the theta A value is 0 because it is a fixed support, there won't be any rotation. In the fixed support there won't be any rotation. Upon simplifying this, I will be getting MAB equal to minus 40 plus 0.5 I am getting because 2 into 1.5 is 3. Okay. And 3 divided by 6. So I will be getting 1 by 2. So at that I am writing 0.5 EI of theta B. So we framed the equation 1. Now we have to go for equation 2. What is the equation 2? Equation 2 is MBA. So MFBA plus 2 times of EI by L into 2 times of theta B plus theta A, and then not writing the support settlement. So here also I can put simply A is 0. I put simply A is 0. So M BA equal to MFBA is plus 20 plus 2 times of E. I value for span AB is 1.5 times of I by L is 6 meters. I will be having here 2 times of theta B. Okay. So let's simplifying this, how much we are getting, just substitute the value of L also. I forgot to include it. This is 6 meters. L is 6 meters. So divided by 6. So if you simplify this, so 2 multiplied by 1.5 will be getting 3. Okay, 3 multiplied by 2 again, it becomes 6. 6 divided by 6, it will be get cancelled. So we'll be having 20 plus EI into theta B. Why we have a EI? Because 2 multiplied by 1.5, this will give me 3 multiplied by 2 divided by 6. So we'll be having 6 by 6, so that we got this value. So this is equation 2. Let's go for MBC. It's a second span. So the formula is MFBC plus 2 times of EI by L into 2 times of theta B plus theta C. Here I cannot able to put 0 for theta B as well as for theta C because both are simply supported. So MFBC value we know. What is MFBC? MFBC is minus of 20 plus 2 times of E. I value for span BC. Let's go to the previous slide. BC is 2I. So let's substitute that value. 2 times of I, and the span is 4 meters. Then 2 times of theta B we are having, and theta C. Let's simplify this. 2 2s are 4, and then 4 4 will be get cancelled, and another 4 is there here. Okay, so how it will come? We will be having minus of 20 plus, so these will be get cancelled. 2 multiplied by 2 by 4, so it will be get cancelled. Only we have a 2 times of theta B. So 2 times of EI theta B, and then plus EI theta C. So this is our equation 3. So quickly we can go for the another equation, which is MCB. MCB is equal to MFCB plus 2EI by L multiplied by 2 times of theta C and then theta B. Okay. Now again we have a C and B. We cannot able to make any terms 0. But here I can put the MCB is 0. I can put MCB is 0. What is the reason? Because MCB is a simply supported condition here. Here MC is 0. It's not an intermediate support as well. So the simply supported moments are 0. Since it is a known value, you substitute here directly, it's going to reduce the few steps in the problem solving. So 0, MFCB is 20 plus 2 times of E, I is 2 times of I by 4, and then 2 times of theta C plus theta B. Okay. So again here 4 4 will be get cancelled. So 0 is equal to 20 plus 2 times of EI theta C plus EI theta B. Okay. So I'm going to write it in proper form, which is EI into theta B plus 2 times of EI theta C equal to, this 20 will go right another outside the equation, so it will become minus 20. So this is our the fourth equation. So far we never got any values because two unknowns are there, and we now substitute the boundary condition. We now apply the boundary condition to get the values. So just applying the boundary condition. So it's not a boundary condition, it's the equilibrium equations. So we have two equilibrium equations here. What are those two equilibrium equations? This is our beam, first, second support, third support. This is A, B, C. Now the equilibrium equation is, we are going to have the MBA value and then MBC value. So MBA plus MBC equal to 0. In another boundary condition also, MCB plus MCD equal to 0. CD span we don't have, but this is also equilibrium equations. So let's substitute this value. So I'm simply going to write the equation for MBA. You see here MBA we calculated here. MBA is 20 plus EI, 20 plus EI into theta B. Okay. So just apply 20 plus EI into theta B. Then MBC is minus of 20 plus 2 times of EI theta B plus EI theta C. So 20 will be get cancelled, EI plus 2 EI will become 3 times of EI into theta B plus EI into theta C equal to 0. Let's make this as a equation 5. Now I am going to solve for equation 4 and 5. I am going to solve for the equation 4 and 5. So what is the equation 4? The equation 4 is EI theta B plus 2 EI theta C equal to minus 20. So let's write the two equations. EI theta B plus EI 2 times of EI theta C equal to minus 20. So this is our fourth equation. Okay. Then 3 times of EI theta B plus EI theta C equal to 0. This is our fifth equation. Now you see two equations and two unknowns are there. So we can directly enter the calculator, select the two unknowns and then substitute the coefficients 1, 2, minus 20 for the first equation, and for the second equation the coefficients are 3, 1, 0. So directly we are going to get the values. So we will be getting EI theta B is equal to 4, EI theta C is equal to minus 12. So in other words, theta B is equal to 4 by EI and theta C is equal to minus 12 by EI. Now substituting back this theta B and theta C in all the equations, we are going to get all the final end moments. Let's quickly substitute it. So MAB, just writing the MAB equation, which is minus 40 plus 0.5 EI theta B. So this is our equation 1. In this equation, I am going to substitute theta b is equal to 4 by EI. So let's substitute it. MAB is equal to minus 40 plus 0.5 EI. Theta b is 4 by EI. So EI will be get cancelled. So we'll be getting MAB is equal to 24 kilonewton meter. Similar way, we'll substitute MBA also. MBA equation is 20 plus EI into theta B. So this is our second equation. Let's substitute this theta B value here. MBA equal to 20 plus EI. Theta B is 4 by EI. EI will be get cancelled. So I'll be getting MBA equal to, okay, sorry, this is not a 24. So this MAB value is minus of 38 kilonewton meter, and then BA value is 24 kilonewton meter. Okay. So MAB minus 38 kilonewton meter, MBA is 24 kilonewton meter. Now we are going to write the value MBC. So MBC equation already we have, which is minus 20 plus 2 times of EI into theta B plus EI into theta C. So what we are going to do here, theta B we are going to substitute 4 by EI, theta C we are going to substitute minus 12 by EI in this equation. Let's substitute. MBC is equal to minus of 20 plus 2 times of EI, 4 by EI plus EI minus of 12 by EI. So EI will be get cancelled here. Then after adding all the values, I am getting minus 24 kilonewton meter, which is MBC. So MCB we no need to substitute because it's simply supported. Directly we can write MCB value. Okay. So from these we computed all the moments. Okay. So I'll write all the moments values here for your reference. We calculated MAB is minus of 38 kilonewton meter and MBA is 24 kilonewton meter and MBC is minus 24 kilonewton meter and MCB equal to 0. Okay. So here you see it's satisfying the equilibrium condition. MBA plus MBC is equal to 0. So we need to draw the shear force and bending moment diagram for this, which is a tedious and bit lengthy calculation. So we'll see all those things in a next lecture. Okay. Thank you for watching this lecture. Thank you.